In this video, we're covering the addition rule of probability, and it mainly focuses on non-mutually exclusive events. So that means events that can have shared outcomes. So for example, we have a set of 20 cards and they're labeled from 1 to 20. One card is drawn out at random, but we want to find the probability that the card will be a number greater than 15 or an even number. So there's two things going on there. The first thing is that it's a probability that it's going to be greater than 15. So that means we could include cards such as 16, 17, 18, 19, and 20. And down here we have the probability of it being an even number. So 2, 4, 6, 8, 10, 12, 14, 16, 18, and 20. So we can find these probabilities. So maybe I'll do this actually. This can be the sample space. So these are my sample spaces. And now we're actually going to find the probability of getting greater than 15. So that's going to be 1, 2, 3, 4, 5 because it's 5 numbers greater than 15 over 20. And then the probability of being even is going to be 10 over 20. Now the problem is sometimes a common error is just to go, well, if it's both of them, I'm just going to add those probabilities so it's 15 over 20. Why this is a problem is because there's what we call shared outcomes. So 16, 16, 18, 18, and 20, and 20. At the moment, if we just added those two things, we'd be making an error because we're counting these things twice, when in reality, they don't occur twice in the number of cards. So when we're doing this, we need to make sure that we're minusing any of our shared numbers. So the probability of our shared is 3 over 20 because there's 3 shared numbers. So this is where the addition rule comes in. The addition rule for this example would be that the probability that is greater than 15 and even is going to equal the probability of greater than 15 plus the probability of it being even minus the probability of the shared outcomes. So in this case, it's going to be 5 over 20 plus 10 over 20 minus 3 over 20. We end up with 12 over 20, which we can simplify down to 3 over 5. Okay, so it's important to remember that if there are shared events, we've got to make sure they're eliminating them because we don't want to double up on that because we will get the wrong probability. So here's another example. We have a survey of 80 people with dark hair or brown eyes. 63 had dark hair, 59 had brown hair, and we want to create a Venn diagram and find the probability that a person has both brown eyes and dark hair. So we're going to quickly whip up a Venn diagram, and we know that 63 had dark hair, 59 had brown hair. Problem though is that if you add those together, 63 and 59, we get a number much larger than 80. We end up with 122, but there's only 80 people that did it. So this will help us find our shared, which goes in here, our shared amount of people. So that's going to be my 122 take away 80. So 42. So 42 people had brown and dark hair. All right, so over here we can do our eyes. So brown eyes. And over here we had dark hair. All right, so now that I know 42 was shared, I can minus that off of the 63. So 63 minus 42. So that was dark hair. So 21 had dark hair. And over here, 59 take away 42 is 17. So 17 people had brown eyes. Now, if you added them, 17, 42, and 21, you'd get your total of 80 people. All right. So the last part of this question was to find the probability that a person had both brown eyes and dark hair, so the probability of both. And that's just your shared in the middle here, so that's going to end up being 42 over 80, which simplifies to 21 over 40.